Good morning, everybody, and welcome back to Next Door NetAdmin. Today, I'm doing something a little different at my house, and it's topical, so I thought I'd talk about it. What we're doing is we are opening a time capsule. We loaded it with a bunch of stuff 10 years ago, and we're going to be opening it today. And there's other stuff in there that's set for another 10 years, and we're going to be adding more stuff into it to be opened in the 10 years or even in 20 years from now. This is just a little ongoing project that's been happening at my house. But one of the things that you might think of including in a time capsule might be some digital media. Whether that's a CD that you really like and just want to set yourself up for a nice surprise in the future, or maybe you want to take some photographs, some digital photographs, and save them so that you can go back in 10 years and look at who all was there. There's some really interesting things that you can do with that, but how many people do you think have thought a lot about, will you be able to read it in 10 or 20 or 30 or 50 years or even 100 years if you're really going multi-generational with this? There's a few things to consider. If you cast your mind back 20 years from current day, 2005, what media did we have that was writable, relatively common, affordable, could store a lot of data? We had floppy disks, although those were going out of fashion. Fun fact, I still had to hand in my assignments at university on floppy drives. There were some USB drives out there. They were not necessarily big. They're certainly nowhere near as big as the USB drives you see around today, which is understandable. But you might have had a USB drive. Cool. Let's say, for the sake of argument, that you chose a USB drive. It was the newest thing that was available at the time. It was this flash media that you could just plug it in and write it, and then you could pull it out, and it wasn't as easily damaged as a floppy disk. It didn't require consumable media like a DVD or even later a Blu-ray. So this seems like a good option. And we still have USB interfaces around today. So this seems like a good idea, right? No. Sadly, not so much. This gets a little bit into the physics of it, but if you think of a USB drive and how a computer recognizes data, it's all zeros and ones, right? Well, when you're working with flash media, a 0 is essentially an absence of a charge, and a 1 is the presence of a charge. And yes, I am simplifying this dramatically, so those of you who understand the technology at a little more detailed level, I know I'm glossing over some of the details here. So when you're writing data to a flash drive, you're writing essentially really, really, really tiny charges in a pattern that will be recognized as zeros and ones when you read it back. Okay. How long does a battery keep a charge? Just in normal life. If I give you a brand new battery bought off the shelf, they have a use before date, don't they? Sure, certainly if you charge your phone up or something and you set it aside for like a year, it's probably not going to have the same amount of charge as it did before. To some extent, with a battery, you've got chemistry changes and other factors like that to consider, but it's not dissimilar with flash media. In this sense, there's actually effects called quantum tunneling, where an electron will just at random decide, I'm not here anymore, I'm over here. Just moves. Over time, more of your electrons will start to leak out of the little battery cell where they've been programmed to be. And it will reduce the charge slowly over time until it's reached a point where the drive can't tell if it's a 0 or a 1 anymore. So, yes, it's stable media for, a week, a month, maybe even a year, especially if you're plugging it into a computer, reading it and rewriting it, then it's being recharged, so to speak, and it's fine. But over a long period of time, it's not going to be able to last. Okay. Well, what else was available 20 years ago? I mentioned floppy disks. Were they any good? They were kind of on the way out the door. Was it any good whatsoever? No. because of the way that floppy disks worked, they were really not good for archival. In many cases, the read-write head had to actually be sitting on the surface of the disk, and so it accumulated a lot of wear and tear that didn't age well, even if you were no longer using it. So, not so much. Okay, well, how about consumable media? I mentioned DVDs. We had burnable CDs. We had burnable DVDs. Didn't have burnable Blu-ray yet, but that came later. What about these? Well, the promise was good, but one of the things that we found out is that in a traditional commercial CD or DVD, you've essentially got a metal foil that has been stamped, and it gives the laser that's reading it pits and just lands. I believe it's called pits and lands. Correct me if I'm wrong. But basically, it's zeros and ones represented as light and dark spots when the laser passes over it, and those are fine. But how do you replicate this in a writable CD or DVD? Most of these are implemented using a form of dye. It is a dyed medium that when you write to it, it alters the dye in a way that when the laser passes over it, it's either being absorbed and there's no reflection, or the dye has changed, it reflects the laser light, and it's now a 1. Which is also why when if you burned a DVD partially, or a CD, and you flipped it over, you could see that there was a color difference between the written areas of the disc and the unwritten areas of the disc. That's what was in play there. Okay. But is it shelf stable? The thing with organic components is that everything organic tends to decay over time. Tends to. And unfortunately, these dyes were things that were not hugely shelf stable. They did decay over time. And so in some cases, with particularly bad batches, it might only last a few years. And as the dye broke down, again, the computer reading it could not tell if it was supposed to be interpreting a 0 or a 1. And so what you had written would eventually just become unreadable. Even some that, hung on for more than a few years, after 10 years, after 20 years, the prognosis is not good. So if we wrote to a DVD or a Blu-ray these days, maybe we could read it in another 10 years, but maybe not in 20. Definitely not in 50. Okay, so what are our other options then? Interestingly enough, the more time we've had a media available to us, the better we've learned how to preserve it. If you think about books, manuscripts, the written page, a lot of that stuff, even though it's been hundreds of years, it's still readable. You can still go back and decipher it and study it and make copies of it. Cool. So paper can be used, but maybe not paper that you've printed out from a printer. Because again, that technology is a little, newer. We haven't made it shelf stable with a long lifetime in the same way ink and just a page. Okay, so what are some other technologies that maybe don't go all the way back to ink and paper, because that's not really a great solution for doing millions upon millions of zeros and ones that a computer can interpret? Well, one of the older technologies is tape, magnetic tape. You can essentially get tapes these days that are many gigabytes. And magnetic tape is something that we know how to preserve. We know that we need to keep it in climate-controlled conditions. There is a temperature range where it's stable. There's a humidity range where it is stable. We know you keep it away from random magnetic fields because that's not good for magnetic tape. And while you don't, there was a time, 20 years ago where you would see, tape drives, and it wasn't that uncommon. You don't see tape drives anymore, but they still exist. They still exist in the enterprise, specifically where you need to be archiving batches of, important data that don't need to be online, but you need to keep around for a while. That's where you'll find tape. So tape is still a medium that you can use, and properly cared for, it will last for decades. Okay, so that's an option. Perhaps a less accessible option to people right now, but it's an option that's out there. What about other magnetic media? Hard drives, maybe. Hard drives are a little bit of a different case because, first of all, how do you connect your hard drive? If you were 20 years ago, you might have an IDE-based hard drive. No computer that I know of has an IDE interface now. Maybe you had first-generation SATA, and there's some SATA ports that you can plug into now. Albeit they're all SATA 3, they're not SATA 1, but you can probably make it work on the interface level. Now, if you have a hard drive that hasn't run in 20 years, is the motor still going to spin up? Is the firmware still going to be readable to the drive controller? Because again, that needs to be saved on something roughly analogous to flash media, although it's not the same thing, and it is perhaps slightly more durable, especially if it's something called EEPROM or heck, any sort of PROM, really. Is it going to spin correctly? Is it going to read correctly? These are all questions. If you have a hard drive that hasn't been spun up in years and years and years, turning on a hard drive is the most stressful part of its life cycle, is being turned on. Once it's running, it'll run for a long, long time. But actually going from a standstill up to operational capacity is the time when it is most likely to fail. So if you're doing this with a drive that's maybe 20, for the sake of argument, let's say 50 years old, that's when it's most likely to break, is when you turn it on to see if you can read it. Well, I mean, I wouldn't say it's a full loss if you have hard drives, let's say in ZFS, because sake of argument, although any file system with proper redundancy would also work. If you turn it on once every few years and do a check of the array, a scrub in ZFS or a scrub in Bitterfis or any of the others with redundancy built in, you can verify that the data is all still good, and you can verify that the drive health is okay. If a single drive fails, maybe you just replace it, and you're preserving your data through time on an array with members that are just powered on very infrequently. But this requires administrator effort, and it's something you probably wouldn't want to do with a standard RAID array, because if you do it with a standard RAID array, you're now introducing another point of failure. Your RAID controller also has to be intact, and your RAID controller's interface still has to be available on a host system versus, a file system that you just point the computer at the disks and say, interpret this really old file system. Okay. What other options exist? Because we've covered USB flash media, we've covered tape drives, we've covered CD drives, or just generally optical media, and we've covered hard drives. Well, there's a couple of other options available. Remember how I said that writable CDs and DVDs were commonly based on an organic die? What if it wasn't organic? What if it wasn't a die? What if we had something that we could use a laser to write, but it wasn't organic, and it was something that we could expect to last for a long time? This is the concept behind something called M-Disk. M-Disk media is compatible with CD or DVD drives. You can theoretically put an M-Disk DVD into any DVD drive and you should be able to read it. Same with an M-Disk Blu-ray. If you put an M-Disk Blu-ray into a standard Blu-ray drive, you should be able to read it. You probably need an M-Disk compatible drive to write it in the first place, but after that, you should be good. So how does this work? M-Disk uses a glassy carbon substrate, from what I've read. Glassy carbon, what that tells me, and again, I could be wrong about this, so if you have more knowledge, feel free to let me know. But as I understand it, M-Disk is essentially, with a glassy carbon substrate, melting bits of the substrate to form, again, something that's shiny, and that's going to reflect light, and that's a 1, or something that doesn't reflect, which is a 0. Something similar to that anyway. And because it's not organic, because it's just carbon, glass will last forever, essentially. It's fused carbon. It's not going to just decay and fall to pieces. It might erode over time. So theoretically, this should last for a long, long, long time, right? Yes, but the substrate is still sandwiched in between pieces of plastic, essentially. Polycarbonate plastic. And while that is not going to decay as such. Something that does happen to plastics over time is they discolor. And if they're discoloring, you might get to a point where a laser is not able to properly read the reflection that has to go through the plastic, hit the substrate, and then come back through the plastic. So over long periods of time, even M-Disc may not be the perfect solution. But we're talking something on the order of 1,000 years. So for all intents and purposes, certainly for anything within any of our lifetimes, that should theoretically be okay. Another option is microfiche, interestingly enough, because photographic film is something that we know how to preserve. So if you converted your data into a human readable form, whether that's text, whether that's pictures, whether that is a visual representation of a sound wave, then you might be able to do something with that. But it's not going to be great for video. It's not going to be great for 3D models or other complex data that isn't easily captured and represented in a static 2D photographic film fashion. And lastly, most of the technologies that I've been talking about, certainly in terms of optical discs, are what has been termed worm media. WORM, write once, read many. Which is, many times, yes, you can read it many times, but maybe not as long as you want a time capsule to last. There is also some experimentation that has been done with a corresponding, bit of kit that was called WARF. Write once, read forever. And it used inorganic compounds, in this case, silver halide. And again, we're working with the same principle of reflections of light, but it was much more complex because it worked with entire wavelengths and wave patterns of light, interfering with each other constructively, destructively, and it was pretty fixed. I mean, this was an experiment that they took up to the International Space Station to see how it handled the rigors of space and brought it back down again. That is clearly way beyond anything that we can access ourselves in the current day and age. But it's interesting to know it's still an area where research is being done, because archiving our digital creations is all part and parcel of keeping our history now. It's no longer just what can be committed to page or even to tape. There's all the other stuff to consider too. So, just an interesting topical little thought that I thought I'd chat about for your interest. Hopefully this has been of interest to you. Maybe it sparked some thoughts. If you have thoughts that you want to share, comments, questions about anything I've talked about, questions about other things that you would like to see me talk about, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door net admin, and we will see you next time.